Welcome to Maratha Vidya Prasarak Samajas, KRT Arts, PH Commerce and AM Science, KTHM College, Nasik. Myself, Prof.S.S.Demse, working as Associate Professor in Department of Electronic Science. Dear student, we already discussed the topic Interrupts Part 1 in previous video lecture. In today's video lecture, we are going to discuss the Interrupt Part 2. Interrupt pins in 8051. So these are the interrupt pins we used in 8051s as an interrupt signal, that is INT0, INT1. So this is for external interrupt. Next one is T0 and T1 for timer interrupt. So these are the four different pins work as interrupt signals in 8051 microcontroller. Now what are the different interrupts in 8051 microcontroller? 8051 microcontroller has 6 interrupts, and these interrupts are as follows. First one is a reset interrupt, hardware interrupt. Timer interrupts, it has 2 interrupt, timer overflow TF0, timer overflow TF1. This is for timer flag overflow for timer 0, and this is for timer 1. External interrupt, it also has 2 interrupts, that is INT0 and INT1. So 2 interrupt for external hardware, INT0 and INT1. Serial communication interrupt, TI and RI. So these are the serial communication interrupt. So these interrupts used in 8051 microcontroller. To enable and disable all these interrupts, in 8051 there is special function registers used. That one is interrupt enable register IE and interrupt priority register IP, interrupt control register TCON. So one by one we are going to discuss these register in details. So first one is interrupt register, interrupt enable register IE. It is a 8-bit register. It is a bit addressable register having format like this. So this is the interrupt enable register. It is a 8-bit register having 8 bit like this, and total interrupt are EX0, ET0, EX1, ET1, ES. So these are the interrupt signals, and this is controlled by this external access bit, which is named as global bit. So when EA, external enable bit, enable or disable all interrupts sources globally. When it is equal to 0, disable all interrupts. So when this bit is equal to 0, all these interrupts are get disabled. So when it is enabled, that means EA is equal to 1. Enable specific interrupts. So any one of the interrupt get enable or enable, but when this EA bit is equal to 1. So that means when this bit is equal to 0, all these interrupts get disabled, and when this bit is equal to 1, they get enabled. So next one is ES, that is serial communication interrupt, enable or disable. UART means universal asynchronous receiver transmitter. So this is inbuilt IC in 8051, and this IC transmit and receive the signal and using this interrupt. When this pin is equal to 0, ES is equal to 0, this flag is equal to 0, UART interrupt disable, and when ES is equal to 1, UART interrupts enable. So for serial communication, these two interrupts are used. ET1 bit enable or disable timer 1 interrupt. When this bit is equal to 1, timer 1 get disable, and when this bit is equal to 1, timer 1 interrupt enable. Okay, so this is the ET1. EX bit enable or disable external interrupt through external interrupt INT1 pin. When this pin is equal to it, this flag bit is equal to 0, EX1 is equal to 0, interrupt on INT1 disable, and when this is equal to 1, then interrupt on INT pin will be enable. Next one is ET1 bit enable or disable timer interrupt T0. So this is the timer interrupt. When this ET is equal to 0, timer interrupt T0 disable, and when this ET is equal to 1, timer interrupt T0 is enable. EX0 bit enable or disable external interrupt through external pin INT interrupt INT0. When this bit is equal to 0, interrupt on INT0 is disable, and when this EX0 pin is equal to 1, then this interrupt get enable. So these are the various interrupt used, enable or disable by using the interrupt enable register. Now how this, I will take one example how this interrupt enable register select the various interrupts. Now first example, find the hex code for interrupt enable register IE to enable external interrupt 0 EX0. Suppose this interrupt to be enable, so what will be the content of IE register, interrupt enable register? And for that, so as we know, to select all these 4 interrupt, so this flag bit EA should be 1, so we keep this 1, then this bit will be get selected, these flag bits will be selected. So these two are 0 0, they are unused. This ES for serial communication, this will be 0. We are going to keep external interrupt INT0 1, and then others will be 0. So this will be 1, all others are 0, this should be 1. So the number in nibble form, so this will be equal to 1 in hexadecimal. All these are 100 means it is 8 in hexadecimal. So we should load in interrupt enable register, move this content IE is equal to 81H. So this is 8, this is 1, and this is hexadecimal number. So enable the interrupt and external interrupt 0, that is EX0. So this is for this interrupt enabling. The second one is, this is the answer of that question. Second example, find the hex code for interrupt enable register IE to enable timer 1 interrupt ET1. So this one we are going to enable. So what will be the hex code? All others will be 0. So for that, so this remains as it is. We should have EA should be 1, all others are 0, and ET1 should be 1. For that, so this is 1, all others are 0. So this gives us the lower nibble, that is 81000 binary, that is in hexadecimal 8, and this is another bit, and that is also 8. So 88H, when we load MOV hash 88H, then enable timer 1 interrupt ET1. So this interrupt will be enabled, and for that we need 88H. Similarly, if we want to enable the serial communication interrupt ES1, so what will be the content? And for that, so these are the content. Here ES should be 1 and this bit becomes 1, all others are 0. So this gives us a 0, this is 9. So 90 is loaded in this interrupt enable register, 8-bit register, which gives the enable serial interrupt ES. So in this way we can set the value of interrupt enable register such that any one interrupt can be enabled, okay, by keeping this value in interrupt enable register. So next register, which interrupt to be executed first, that is given by decided by the priority. Priority means importance given by microcontroller to the peripheral, which interrupt to be attended first. So that is the priority of the interrupt. So this interrupt register is a 8-bit register, which is also a bit addressable register having format like this. So this is IP, means interrupt priority register, and these are the priority bit of that. So this PT is used for 8052 microcontroller. So we are having 8051, so this bit will not get considered. So this bit is for higher version. PS, that is serial port interrupt priority. So this bit, if we keep 1, then the highest priority given to PS1. So when it is 0, priority 0. When it is 1, then priority given to first priority or highest priority given to PS1. Next, PT1, timer T1 interrupt priority. When it is 0, this bit is equal to 0, priority 0 means not having priority, and when it is equal to 1, highest priority given to this bit. So this is external interrupt priority bit INT1. When this PT is equal to 0, the priority 0. When PX1 is equal to 1, priority will be higher or 1. PT0, the timer T0 interrupt priority. When this bit is equal to 0, priority will be 0. When PT is equal to 1, the priority register having 1. This is PX0, external interrupt INT0 priority. When 0, priority 0. When it is equal to 1, the priority decided. So the execution of the interrupts will be like this. So here PT0 we may call it as EX0, PT1 PX is equal to external interrupt 0, EX0, PT0 timer 0 we may write like the symbol ET0, PX1 external interrupt EX1, PT1 external interrupt ET1, and this is PS means serial interrupt ES. So how the priority will be decided. Default priority order will be like this. So these are the interrupts and their symbols. The highest priority given to external interrupt 0. Then the priority goes decreasing, and the lowest priority interrupt is a serial interrupt. So by default, these types of priority get decided by the microcontroller 8051. Now setting a particular bit in IP to make the corresponding interrupt of higher priority. For example, if IP is equal to hex 08, we'll make the timer 1 highest priority. So how it is, you see here, this is a IP, and this IP gets selected like this. So this is the bit we keep as a 1. So this 1 indicates 8 and this is 0. So here 8 and this is 0. So this value, if we load in IP, then the highest priority given to timer one interrupt. So here you see this is a default priority, so highest to this and lowest to this. But as we change the load the value IP as 08, so 8 means this 1 is here and which is having highest priority now. So PT1 means that bit is ET1 having highest priority, and the other will be, so this by default this bit is having higher priority, then this, then this, then this. So highest one is timer 1 and the default priority remains as it is, highest to lowest. So this is one example. Another, if suppose two interrupts come simultaneously and we define the priority like this. So this will be PT1 and PT0. So this will be 9, your A value, hexadecimal A. Suppose we load 0A in IP, will make timer 0 and timer 1 priority higher, so that the interrupt priority order will be changed as given in descending form. So if IP is equal to 0A, timer 1 priority higher, then the priority PT, so PT0 will be highest one, PT1 will be second highest, and others will be a default. So this is the priority decided when the two interrupts come deciding the priority same, then highest one will be according to default value. So ET0 having highest, ET1 having second highest. So like this, ET0 having highest, then ET1. So highest will be given to timer 0 and then timer 1, external interrupt 0, INT 0, serial interrupt, and then 8. So this is the having lowest priority. Timer control register. It is a bit addressable special function register. It is a 8-bit register, contains the timer and interrupt flags. So here this is a flag format of TCON register. We already discussed it in timer and control video lecture. So ET0, E, IE0, IT1 and IE1. So these are the interrupt flag bits of TCON register. TR0, TF0, TR1, TF1. So this is a timer interrupts of TCON register. So we already discussed this. Bit 7 is reserved for TF1, that is timer 1 overflow. When it is 1, then overflow occurs. When it is 0, not occurs. Overflow not occurs, or rollover not occurs. Bit 6, that is TR1, start timer 1 control bits. When it is equal to 1, timer 1 started. When it is 0, timer 1 stop. 5th bit, that is TF0, timer 0 overflow flag. When it is equal to 1, overflow occurs, and that is the rollover. When it is equal to 0, then rollover not occurs. Now how the rollover occurs? Now see, suppose this is the initial content of timer, then at that time TF will be 0. It get incremented by 1, then TF also 0, and it having last value 00 FE, then this will be 1, 00 F, and after that it goes to 00. So at that time rollover occurs. So here 00 FF to 00. So at that time rollover occurs, and once rollover occurs, TF becomes set. So this is the condition for overflow. When TF is 1, that means timer get rollover to 00. So at that time this timer TF1 and timer TF0 flag bit gets set. Then next one is start timer and stop timer. Bit 3, that is external edge trigger timer 1 flag when is equal to 1, external timer 1 occurs, and when it is 0, external timer interrupt 1 proceed, that is jumps to interrupt service routine INT1. Bit 2 IT1 external trigger input timer 1 will be there, and for that, so this will be 1 interrupt occurs on falling edge at INT1 pins, and when it is 0, interrupt occurs on low level at INT1 pins. Bit 1, that is interrupt IE0 external edge trigger interrupt 0, when this bit is equal to 1, external interrupt 0 occurs, and when 0, then microcontroller proceed that external interrupt, jumps to ISR of INT0. Bit 0, that is for IT0 external trigger input INT0, when this bit is equal to 1, interrupt occurs falling edge at the INT0 pin, when it is equal to 1, then interrupt occurs low level at INT pin 1. So in this way, this bit get control all this by timer and control register. So upon the edge triggering pulse on INT0 INT1, the 8051 set IEX bits of TCON register. Only the execution of iReturn instruction at the end of ISR will clear these bits. Means according to these bits, this bit gets selected of timer control register. Now interrupt vector table. So as we know, the interrupt vector table is given by the interrupt service routine address. So this is a name of interrupt, this memory, read only memory location in hex, pin and flag clearing. Reset having the memory address 000H, pin number is 9. External hardware interrupt 0, that INT0 having the address, interrupt vector address 0003H. Timer 0, interrupt TF0 having hexadecimal address 00BH. External hardware interrupt 1, INT1 having hexadecimal address 0013H. Timer 1 having address 001BH. And serial interrupt RI and TI having 002H address. So these are the pins of that interrupts. The read-only memory location 00 to 30 are used as interrupt vector table. So that we are going to discuss. When an interrupt is involved, the microcontroller runs the interrupt service routine. For every interrupt, there is a fixed location in memory that holds the address of its interrupt service routine. A group of memory locations set aside to hold the address of interrupt service routine is called as interrupt vector table. So this table consists of the addresses like this, and that addresses start from 00H and end at 003H, and having all these interrupts in that. The first address, as we know, so that is the address of a restart 000H, and 3 memory location used for that. So that hold the instruction name as interrupt service routine. To attend the interrupt means execution of interrupt service routine. Next interrupt is interrupt int0, whose vector address is 003H, and this is the interrupt service routine for int0. 8 locations are reserved for it. Next interrupt is TF0, timer flag overflow flag, TF0, so having address 00BH, and this is the 8 location reserved for interrupt service routine. To attend the interrupt means, to process the interrupt means execution of interrupt service routine, execution of these 8 instructions. Next one is having interrupt, external interrupt int1, having address 0013H, and this is the interrupt service routine for this interrupt. Next one is TF1, having address 001BH, and this is the interrupt service routine for that. Again, the serial interrupt RI and TI, having the address 0023H to 0030H. So this is the interrupt service routine for serial interrupt. So this table is nothing but the interrupt vector table, and these are the addresses of these interrupts. And microcontroller always attend this interrupt by executing ISR, interrupt service routine. Now interrupt response of 8051. When the interrupt occurs, the activation of interrupt, the microcontroller goes through the following steps. So these are the steps executed by microcontroller. Now how it is, you see. When the program execution is going on, main program execution. So this is a main program execution, and interrupt occurs. So when the interrupt occurs, the program counter register, so it is always hold address of next instruction. So that program counter content push on stack, that is push PSW register, push PC, and clear the interrupt flag. So this is done by when the interrupt occurs by microcontroller, and the new address of PC is the address of ISR, that is from interrupt vector table. So this address is the address of interrupt vector table, and here the interrupt service routines are stored. So this push instruction, so this will be again interrupt service routine. So that address instruction executed by the microcontroller. After executing this iReturn instruction, microcontroller PC will pop first, then PSW register, flag register, and then back to main program execution, a restart. So these are the steps executed by 8051 to attend the interrupt when interrupt occurs. Now, so this is the first step. It finish says the current instruction execution and save the address of next instruction PC on stack. So this is stored in first step. Second step, it also save the current status of all register like PSW register, flag register content will be stored on stack, and jumps to the to fixed location in memory called as interrupt vector table, and then jumps to this interrupt service routine. The microcontroller gets the address of ISR from interrupt vector table and jumps to it. So this is the table, and that gives the address of ISR, interrupt service routine. The microcontroller start to execute the interrupt service routine until it reaches the last instruction, which is iReturn. So this is iReturn is the last instruction. When the last instruction executing the iReturn, the microcontroller return to place where it was interrupted. Again, this is the last instruction and it has to go in main program execution. So stack content will be popped. First, it gets the program counter PC address from stack by popping the top 2 bytes of the stack into the PC, and then it start the execution of the main program address. So this is nothing but the response of 8051 when interrupt occurs. The next one is interrupt structure of 8051 microcontroller. So this interrupt structure consists of the following blocks like this. So this is the first interrupt. Now INT0, INT1, external interrupt, and these interrupts having this hexadecimal vector address 0003. The first one, INT0, when it enable level trigger, that enables the TCON register E0 such that this address get generated. This is address of interrupt service routine. Now there are interrupt enable register, interrupt priority register, and then according to their priority, interrupt get executed by the microcontroller. So suppose this INT0 interrupt occurs, it may be level trigger or edge trigger. This enable, when it is enabled, then this IA registers, the EA bit is equal to 1, then this will close, depends upon EX. Then according to their priority, if it is having highest priority, then this is shifted here. If it is lower priority, then given to the execution or interrupt the microcontroller. When INT is equal to 1, so this is second interrupt occurs, suppose, who is having external interrupt vector address 0013. So these things will be happens, and then this interrupt get enabled and then interrupt the microcontroller. Now there is timer interrupt TF0 having hexadecimal address, that is vector address 000B, and then this is executed. By default, these types of execution will be done. Then TF1, timer 1, 001F is the vector address, and then the serial interrupt RI and TI, whose vector address is 002. Now in this way, these interrupts get selected. Now the very important task we are going to explain here, the use of this global enable bit. When EA is equal to 0, so all these interrupts will be disabled. No interrupt get interrupt the microcontroller. But when it is equal to 1, means all these switches are closed. When these switches are closed, means according to this interrupt enabling, this interrupt get interrupt the microcontroller according to their priorities, highest priority, lowest priority decided by IP. Okay, so when this is equal to 1, then individual interrupt enable by using EX1, EX0, EX1, ET0, ET1, and this is ES, the off interrupt enable register. So in this way the interrupt gets selected. Now when ES is equal to 0, then this interrupt is disabled, and when EA is equal to 1, then this is enabled, means all these switches are closed, and this response of external interrupt, timer interrupt, enabling and disabling of serial interrupt get selected, and these device get interrupt the 8051. Microcontroller attend that one. So this is the interrupt structure of 8051 microcontroller. Thank you. I think you may clear all the points related with interrupts. Thank you very much. If you have any questions, contact on my mail ID Demse57@gmail.com. My mobile WhatsApp number is 9860389302. Thank you.